it's my pleasure to be able to invite my colleague Matthias Rolf to give this talk for Smart Visitor Management. Matthias studied Computer Science MSc in 2008 and then did his PhD at Bielefeld University in 2012. He has also given a BCS talk about robot learning on this PhD in 2016. He was a specially appointed assistant professor at Osaka University in Japan from 2013 to 2016. Starting at Oxford Brookes as a senior lecturer, he is now a reader in computer science. He's interested in applications of AI and machine learning to complex systems, including robots, autonomous vehicles, and businesses. So welcome, Matthias, please.
Thank you very much. Thank you for having me here. It's great to be back, since I've talked to many of you quite some years ago now. And at that time, it was about robot learning. And this is one of the areas I am interested. It's using machine learning for systems that change, that act, that talk back to you. So I'm still doing robotics, but I'm also investigating very heavily in other things that talk back, that act, that move, that you need to control. And one of them is a very particular business, which is Blenheim Palace. And that is the project I'm going to talk you through a little bit today. I should first of all say that this is a collaborative project between them and us being actually a Brookes internal collaboration as well. There is me. I'm from computing, and I'm working together on this with colleagues from the business school to give justice to the very interdisciplinary nature of these kind of endeavors. So most of you probably have seen this palace in some shape or form. It's quite gorgeous. Famously, the birthplace of Churchill, some heritage, and really just a very nice place to visit. It's nice being there in the landscape. Beautiful buildings. You might go there for things like the lights, really nice ones. And what Blenheim does in order to sustain really the upkeep of its heritage, it's every day, which is how they maintain this grand house for the public. And I'm not going to torture you too much with the historic background of the palace. There's a lot to tell you that the palace houses are much more capable of than I am. So what do people like us do with them? Okay. So Blenheim, as it turns out, is, despite the historic outside and appearance, a very innovative innovation, and has been capitalizing, recording on data for quite some time. They have, in fact, a very extensive data operation for all kinds of things. They have all the normal IT systems that you would expect a visitor attraction to have, from ticketing systems to event management, to catering, billing, and so on and so on. You have all of these IT systems generating data. You have on the inside of the palace sensors that monitor temperature, humidity, to keep just the right level to let the interior of this historic site not deteriorate. You have a lot of outside sensors that capture all kinds of things, projects regarding ancient bee population, you name it, they have it. It's a really huge operation. And people ask very quickly what you can actually do with this kind of data. So you're recording all of these kind of things, and the geek inside all of us is very happy that you have all of these systems. But how are you actually going to make a difference for your organization? Are you going to pay for this? How would you explain your manager or your head of finance why they should be spending money on this? Is it worth it? This is something that we've been investigating from the starting point that about in 2017, they already had a lot of dashboards that looked like that, that would take in a lot of the data they had on how their business is running at the moment. And it would give reports to management, how the last quarter was. And it was already quite ahead of what most people in the sector had in terms of actually pulling this from their IT systems automatically. But very fundamentally, it was all backwards looking. It was always about how was yesterday? How was the last quarter? How was the last year? It was never about what's happening tomorrow. And that has been the starting point of a really useful conversation that we started having in 2019 about how can we do better than that, right? How can we actually use the data capabilities that these organizations have and make a difference to their business, look into the future, make better decisions for tomorrow, next week, next year. And it's been really about, first of all, just bringing that data together. Most organizations, Brookes is a great example of that as well. We have tons of IT systems. They're all sitting there somewhere on some server. None of them talk to each other. It's a great pain to make anything talk to anything else, let alone run analytics on it, right? So a lot of it was about how can we actually pull this together, have a single source of truth from which we can. How can we deal with all of the things that inevitably are going to be wrong with that data? There's always going to be something wrong with that data. Some of it is noisy. Some of it had been inputted wrongly. Sometimes systems have flaws and so on. And how can we then eventually use that to really build a good contextual understanding of what's happening? How can we give them an understanding of what should we expect over the next week? How many visitors are coming? What should they be resourcing for? How many sandwiches do they need on Friday? Believe it or not, lack of sandwiches is one of the most common customer complaints they get. It's very bad if you go there and the sandwich is sold. And that's fundamentally an error of prediction. You just haven't thought of the numbers that you're going to get. And a lot of these problems are of the sort that if you talk to a manager or a supervisor or a host on their side, they'll have a pretty good intuition about some of these things, rarely on many, but on some that really correspond to their function most closely. They will have a pretty good understanding that, well, okay, on a sunny day, I expect more visitors, and they'll be having some intuition about how many more they would expect on a really sunny day, even though we'll get to that. There's often some misconceptions as well, and not all intuitions are actually right. You'd think that more tickets corresponds to selling more coffees, selling more ice cream, selling more cakes. But how much actually? How much should you actually be planning for, right? There's pretty difficult things to actually work out accurately. And so we had a lot of questions, and we started together on putting a bid in to the government, to University UK, for a knowledge transfer partnership. It's a very particular funding model that is commonly described as a relation between three entities. One is a company, one is a university that holds some sort of a skill or knowledge that should be embedded over the course of a project into the company. And the third one being one associate, which is typically a fresh graduate, who works on this project and develops and eventually works to embed these capabilities into a company. So this is the team you see on the top at Blenheim. This is David Green, who's head of innovation at Blenheim. There is me from computing, Paul Jackson and Diana Limburg, who are in business school. Over here, Yayoi was our first associate. She got an exceptionally good job offer, very close to finish time of the project, which meant, unfortunately for us, but good for her, she got a very good job. We had to look for someone else, and we found Tahit over here, who still now, after the KTP, in fact, has completed already, works for us under a slightly different umbrella. There's tons more people who actually have contributed to this. lots of people at Blenheim in various management positions, but also actually lots of people at Brookes, students in particular. We've had about 10, I counted yesterday, students projects actually in this area, master as well as undergraduate project in both subject domains. So it's been a very rich environment, I think, for launching projects and investigating very interesting capabilities. And we did this application initially in 2019. Now, some of you remember that around the time 2019, 2020, some major world events happened. And that meant for us that, well, we got the funding, but here we are in March 2020 trying to launch a research project. Yeah, those were interesting times. Actually, we couldn't. And we had the money and we had actually the person. But with all organization having hiring stops and stuff like that and needing really to look for their money when we just went into lockdown and everyone stayed home, we decided to delay a bit. We managed to start in July 2020. And it was a very interesting time, obviously very difficult time still for many people, 2020, 2021. But it was an interesting time for a project like this, I would say. And I'm going to show you some things that directly relate to the COVID challenges here as well. So what did we do? The first thing that we really had to do was build the infrastructure, right? Make sure we have all of the information, make sure that the information talks into the right systems when and where we need it. So very big effort, actually, in particular from our associate and from David at Blenheim, spent into getting all of this data integrated and getting the sensors even out there in the wild, in the parks, to talk to our systems. And this is since then, let me try whether I can move this here. Really critical part of this has been investing in IoT infrastructure, which is how most of these sensors are collected these days. So what we're using to collect all kinds of data from not just the buildings, but also from the parks, sensors that count people, temperature, everything you can think of. They all talk into the so-called LoRaWAN technologies, low power, long range communication. That means you can put a little device like a people counter somewhere in the park without power supply, and it will sit there and it will send you data for months before it needs a battery change. Right? And that's been really important on a very complex site like this. As you've seen in the video, there's buildings, there's huge parks, and then at the end of the park, there is another bunch of buildings you're interested in. So you need to bridge all of these scales, and this kind of LoRaWAN technology has been really, really powerful and instrumental for us for getting all of this data actually in. This is all integrated. And this is where we really, really talk about infrastructure building into a fairly expensive to run, but worthwhile operation into what we call a data hub. This is at the end of the day some SQL database, but it's one that's very cleverly managed through the cloud. And basically what we're doing in there is we take all of the data we can get our hands on, everything, ticketing, retail catering, CRM, sensors, traffic data, surveys, put it in there. That sounds easy. That sounds something anyone would be doing anyway, but believe me, that's a lot of work. This has been probably close to half a year of just setting this up, even with the help of a consultancy and obviously using tools. This happens on the Microsoft Azure stack. It has been taking a lot of resource to just set this up, to have the right transformations of the data. Think of all of these systems using different date formats, any possible complication with data that you can imagine happening here, right? So this is something that we're still seeing today, where we made, I think, a very good investment, and something that already puts us in front of most of the sector is we've built actual data infrastructure. And I'll tell you a little bit more later about a lot of the problems we have in engaging with other organizations is that not only do they not have AI, they don't have this infrastructure. So it's a pretty long way. This has been working quite smoothly since then, but make no mistakes, that has uptake cost as well. So you need someone to actually look after this. IT systems change, the transformations have to change. This is something that actually does need an expert to also look at to just keep it up, of course, at a lower rate. And basically what we're doing is we're taking everything out of that thing, which eventually is an SQL database. And all of the applications we build now talk to the single source of truth. Right? All of the machine learning algorithms, the reports, all of the dashboards come from here. And what these things are doing is powering our, what we call smart visitor management system. I'm going to give credit where credit is due. Colleagues in business school always have a better knack for naming things in a fancy way than we in computing have. I think smart visitor management is a great name for the thing. I wouldn't have come up with that, even though that sounds simple. And it is comprised, at least at that time, when we ran the KTP initially, was mainly comprised of two things, and they correspond to two ambitions. Customer insight and prediction means we want to know ahead of the day, ahead of the week, who's going to come, who are those people, right? Are those going to be 2,000 international tourists who want to take the usual tour? Are those people from the local village of Woodstock who have an annual pass and just want to take a tour through the parks? Visitor experience and flow management means we want to know on a much finer time scale, on a level of minutes and hours, what are all of these people actually doing right now? Are they all in the palace right now? Does that mean they all go into the pantry cafe within the next 15 minutes and want a cafe or a sandwich? And both of these things at their different timescales are basically meant to allow them to just make smarter resourcing decisions, right? You want to be able to tell there's going to be a huge crowd coming next day or next hour. Get ready for that. Because if you're not getting ready for these things, you get very bad reviews, and that means very bad business. Famous event in that year when we had the initial conversations with them, 2019. For some reason, they just didn't have the Chinese New Year event on their radar. They hadn't planned for maybe more people than usual coming. So they were completely swamped with tourists, ran out of everything immediately, had far too few staff on site to manage the queues, and it was a disaster. And you might think that, well, okay, they just sold moderately expensive tickets to almost 10,000 people. Isn't that good business? Only in the short term, unfortunately. If they all go home and tell their friends and family how awful it was, that's not going to pay off in the long run. So sites like this really live from their reputation. The reason why any one of us would go there is because we've heard from people around us how great it is. That's why people go there. So you really need to keep up that level of positive experience. And we take these insights that we're generating and we want to deliver them. This is an innovation and a knowledge transfer partnership project. We're not doing this to write a paper. We're doing this to make a difference. Okay, so really the goal is we give this back to the people who can actually do something with it, and then hopefully they actually do something with it. Right? So this is where our competence, of course, stops. We can't do everything for everyone, but we can make sure to use data and AI to give them the best possible information they could have. And that includes staff on the day, that includes management, but that also includes, going back to everyone here, visitors, right? To tell people, well, actually, it's going to be really busy there, or that's going to be closed. This is going to be the demand here. Don't you rather want to do this instead? Go to the cafe first. Have a coffee. Palace is going to be less crowded in an hour from now. That's the kind of level of advice we want to give to visitors eventually. Now, I really want to talk about the AI bits here, and I would guess that at this point most people are familiar with the notion. So I'm going to refer to this very broadly as anything that would normally require human intelligence. It's, I think, a reasonable definition of AI. And this is and always has been a very, very broad set of skills and methods. Just like our own thinking capabilities are very broad and diverse. There's a lot of things that we can do. So relevant to this project, that includes things like understanding signals. That might include things like language as well, recognizing patterns, solving problems, all these kind of things. And very specifically, this is not an exhaustive list. We're using this in this project to predict visitor numbers, predict, analyze visitor movement as it happens. We predict many other things. One of them I included here is actually predict visitor satisfaction. There are standardized ways to capture these. One is called the Net Promoter Score. So we're trying to predict all of these things as well. And do things like summarize reviews to give digests to managers. And there's quite a lot of stuff happening in this project. And has happened over the past 5 years. And I basically want to give you a bit deeper dive into a few of those. And then discuss a little bit what kind of lessons we've learned from this. So the first really big AI data machine learning challenge that we had, and really set ourselves as well, was to track where people are and where they're going. And this came, as I said, at a very interesting time, at which we had gone through one lockdown and people had been considering whether we need another. And we were approaching Christmas. And in 2020, the government actually started to encourage organizations that attractions, nice places to visit. The government started to encourage them to run things again, so that we wouldn't be all sitting there in our rooms locked in and all get depressed. So organizations like Blenheim were sitting there now and thinking, well, okay, how do we run a safe Christmas lights trail with thousands of people every day without overcapacity or running any kind of congestions, people clumping together, spreading the virus? How do you actually do that? And for us, the bottom line, as far as the project was concerned as well, the first point has to be, you have to know where they are at the moment, right? You have to be able to tell, this is how many people are actually in this area right now. And we started to work on this under these very difficult circumstances and started to install more sensors. If you've ever been to the Lights Trail, pretty much in any year, you might know how this picture here looks like at night. That's the light tunnel. That's the most Instagrammed part of the entire Lights Trail, I think. It's quite impressive. It's this huge tunnel that's just completely lit up with LEDs, and everyone takes their selfies inside. What you wouldn't see at night is that in the middle of this, there were two boxes taped to these pillars in a fairly crude way, and those are infrared barriers. And you see these devices in other contexts as well. In shops, for example, you often see them at the entrance, and they work in a very simple way. If you walk through, you interrupt one beam of light, then you interrupt the next beam of light, and it detects that sequence in the direction and counts you as, okay, one person just walked through there. So this is a very basic people counter. It has the advantage that you can actually run it on very low power. You can just stick it in the park anywhere, no power supply, no external light necessary. That's quite important at a nighttime event. Good luck with cameras. Right? So they run under pretty abstruse circumstances. And they give you very useful data about where people are, how they're moving at the moment, which we hoped to be able to use to tell the management and eventually report back to the government. Yes, we know as a matter of fact, there were only 2,000 people at most at any time on this lights trail. And we know relatively well how they were distributed across the trail because we had multiple of these sensors. And this is how we know we didn't have any unreasonable overcrowding. Now, the problem with this thing is that while it's very robust to the kind of environment that is installed in, it makes, of course, all kinds of mistakes, and all sensors do. My background is in robotics, and basically what all we ever do is deal with all of the nonsense that comes back from your sensors, right? It's dealing with all of those imperfections. And this happens here as well. You get all kinds of funny behavior, people walking through in parallel. That means the beam of light is only interrupted once. So you undercount people, right? Some people just won't be sensed because of how they walk through at the same time. You have problems where one of these sensors might get misaligned, so the beams of light don't meet anymore. So you have a gap in your reporting. You might run out of battery for some time. You might just lose a package on the radio on the way. That happens. Right? We all know this from networking, that occasionally these things get lost. So you have all kinds of small things at different rates going wrong with the data. And that is actually a problem you really need to be concerned about when you want to make business decisions based on data, in particular when they are also health and safety critical. So this was version 0 of our people counting, okay? And what you're seeing here is that over the course of time from roughly 3:30 p.m. to 10:30 in the evening, what these lines are showing is how many people are in each of several segments of the lights trail. And what we did was very simple. We took the lights trail. It's just one path, and we divided it in 7 equal parts. We put sensors in between all of them. And then we took all of these segments and said, well, okay, there's a sensor at the entrance. 2,000 people have walked in. The sensor at the exit. 800 people have walked out. So that must mean there are 200 people in the bar. Right? That makes sense. Now, the problem is, if you do that, this is what you get at the end of the day. And just for clarity, at the end of the day, the ground truth is there's no one there at all. But if you do this crude way of counting, well, you'll get that for some of the segments, but most of them, the model would either think, okay, well, there's clearly 2,000 people in that segment, where in fact there is no one. Or worse, it would report, well, there's minus 3,000 people in that segment. And that seems a bit odd. Maybe it should. And that simply has to do with the fact that all of these sensors, they all make mistakes, but they make different amounts of mistakes. And there's all kinds of asymmetries between them. So you can have a situation where you've counted 0 people walking in because the sensor was misaligned, but you've counted 2,000 people walking out. So there's your minus 2,000 people. Now that's a simple example. The problem, of course, is that all of these things happen at the same time, and the boundaries are really not so easy to see in all cases. So how can you make sense of this? And well, this is where I really came in as a roboticist. It's really funny how these things work sometimes. When I started to work with Blenheim, I hadn't considered that my robotics background might be particularly useful for it. But as I said, this is what roboticists do all the time. We make sense of the mess that is the real world, all of the noise, the errors we get from sensors. We try to correct it. We try to understand it. So actually know how to deal with this. I'm not going to go through this math. This is what is called a Kalman filter. And when you're in robotics or you're in control engineering, for example, you know this thing inside out. And basically what it does, it's a massive method of sensor integration. And it's one actually that I would say everyone in this room probably has used on the front end side, because it's the thing that keeps GPSs in cars and phones on the right position. And when you're dealing with GPS signals, you need a filter, because if you use the raw signal, you'll be jumping 200 meters every time you take a reading. And when you go in a tunnel, you have nothing. Right? So you need methods to integrate all of that data over time and to correct for these kind of things. And what it does, I think, is conceptually relatively simple. It takes an initial estimate. So you see there's this nice bell shape over there where it thinks it initially is. And then it does two things repeatedly. The first thing is it tries to make an interpretation or a guess prediction of where it likely is going to be next. So when you're driving a car, you know you have a certain speed, you know the direction of travel hasn't abruptly changed, probably. So you can make a prediction. You forecast yourself. And then in the second step, you take your sensor reading, right? So you get another curve. And then you do mathematics, and you combine these two things into what you think, based on both of these pieces of evidence, is the best estimate for where you are. And there is a closed form to this. This is optimal and so on. And it's a wall of slides that I'm not going to show you. It's pretty horrendous, actually. It's this long on Wikipedia, but it doesn't really matter for us. The key thing is what we can actually do with it. Which is we can apply this kind of principle, the same algorithm, and transfer it from something that normally happens in a control context and apply it here. So here's what we do. We take our very simplified lights train. On the slide, I'm only showing you two segments. So there's some entrance, people walk from the left to the right side. There are segment boundaries at which we would assume we have a sensor. And as people S1, they are counted. S2, people are counted again and again at the exit. And now we model this with a few more steps in between. So we say, well, okay, people can enter here. They pass the sensor. They move through a few more positions. They move through another sensor, and they move on. They might actually stay at some point, right? So they might not go to the next area. They might stay somewhere for any duration they want, but they generally pass through. And this is a very simplified model of how people would actually be moving. But what it does is it gives us something to put into a filter algorithm, because now you have just a list of numbers again that characterizes what state the system is in. When you're driving your car and you're running your GPS, that's where am I on a map, right? X, Y, and orientation. That's three numbers. In this case, we would be trying to track 1, 2, 3, 4, 8 numbers. It's a bit harder to imagine, but it's the same mathematics at the end of the day. And there are some interesting analogies now between this kind of GPS example and what we're doing here, because we would develop this kind of model of how we think the sensor might make mistakes. On the GPS example, that was, well, plus minus how many meters would I expect, or how wide is that bell curve? Here it is, well, okay, if someone goes on that sensor, what's the probability of them being counted? And so that would be a factor in the end of, let's say, 0.9, meaning that if there's 100 people walking through, our expectation would be that we count 90 of them. And then there is a prediction model that just quantifies how quickly we would actually people to go through this chain of locations. So this might be very slow. If there's a very attractive light installation in one of these areas, people would have a low probability to move forward. They rather stay longer in the same place. Or maybe there are locations where they pass through very quickly. And what is very important is that in between, the number of people has to stay the same. That seems very intuitive, I suppose. We called this the conservation of people principle. This is analogous to the conservation of energy in physics. And that is really critical, because if you take physics and you try to solve it without actually specifically putting in the conservation of energy, it won't work. And the same thing counts here with counting people. You need to specifically model that the number of people stays the same, or it won't work. Except sometimes people do appear and disappear. And that's what we call entrances and exits. So there's been some quite creative modeling here, I think. This is quite far from how these Kalman filters or other probabilistic filter algorithms are normally used, but it actually does a pretty good job. For the mathematical geeks here, I will say immediately that none of the underlying assumptions of the Kalman filter are satisfied in practice, but it works nevertheless. So we can safely gloss over that. This is what it looks like at the end of the day. I'm only going to sanity check this with you. I'm not going to prove to you that these numbers are actually the real people counts that were on there. But I think just sanity checking, we can see, first of all, the curves all return to 0. That's a pretty good sign because we know that is true. That's the only thing that we know as a matter of fact. At the beginning and at the end, the trial is actually empty. Now, we've done quite a bit of effort of verifying different aspects of these curves. You see, at most of the days and most of the segments, pretty much everything looks the same. It's a pretty typical curve, what you would expect from a demand. But there are days that deviate. So you see all of these days here where things stop very abruptly, or whether there are these weird minimums over here. And we've actually checked all of those manually. So we know that these were actually early closures. This happens when you, for example, have to close due to wind gusts exceeding certain limits, safety reasons. So you can actually see that in here. These things here actually have been temporary closures. We know that in this particular peak, someone climbed over the fence and broke their arm falling down where they shouldn't have been going. So an ambulance had to come and there was a disruption, but they dealt with it very professionally. The point is, you can see all of these things being reflected in the data. And actually, even if you wouldn't have known anything about that thing happening, anyone looking at the data would have seen there's something going on right now. And then they can do something about it. So this was a big, I think, learning step that we took out of this pilot during the 2020 Lights Trail. Things have grown considerably. This is part of the model that we're using right now. It used to be just one trail. You could only go one way along a circle. That was it. This is the real complexity of visitor movement just in the main palace area. To give you a little bit of orientation, there is a big courtyard in the middle of the palace. Palace basically surrounds that. Then from there, you can go into many different directions through the east courtyard into the retail shop. You can go into the main palace area as well as the Churchill exhibition. Those are different rooms. Or you can go to the other side into the Stables Cafe. There's another exhibition in there. And then basically from there, you can go into the gardens. What's not shown in here is there's more of that on the other end of the estate as well that we've modeled, where we have the maze as well as the adventure playground. And what you're seeing here is basically now our model. This corresponds to those 7 circles in a line that I showed on the last slides. This is it now. So we can actually do this for general graphs now. We can configure this very freely. And every arrow that you see on here is not only a possible way for a visitor to move from one place to another, it's also a sensor. And they're all sensors connecting through LoRaWAN, coming back into our model that allows us to count all of these activities now. Great. Another very big journey that we embarked on was making visitor count predictions. So our ambition has been initially to predict how many people are going to be there about 30 days ahead. And that would include things like, well, okay, we know how many pre-bookings there are. We know what kind of day it is, of course, in terms of calendar. Is it the weekend and so on? All these kind of things matter when you want to make predictions. Weekends are a lot more busy than days. The weather matters, and there's a whole list of these that we already had quite some years of historic data actually on when we just started this project. Those are all quite easily available in some sense. And in fact, it was at the end of the first month of the project. It was summer 2020. when we had the first model that actually made what appear to be quite reasonable predictions based on these features, you might recognize this is a fairly standard task for machine learning. This is called regression. You take a bunch of numbers, you try to predict another number, you have data for both of them. That's more or less off the shelf. So that was within 1 month of the project. And the only reason why it didn't take 1 week instead of a month is there was a mandatory induction period first. So job done. No. We thought well, for a brief period, we thought we just finished the project. It couldn't have been further from the truth. That's when the real work begins, right? Suddenly you have people not trusting your models. Sometimes for very good reasons. You have all kinds of problems with your data. You have things like historic biases. You have all kinds of problems with your data sources. Sometimes things just don't align. The data seems wrong. So that's our starting point. This is a completely standard machine learning task. You can just download a library that does most of this for you, except it won't be as good as you think. So a lot of the work that we did was to, first of all, get a sense of how people would work with these kinds. So here is us, right? We say every row in this is a day. Here is a bunch of predictions. We had already some uncertainty measure of this quite early. So there would be a bunch of predictions in blue saying this is the range in which we think this day is going to be. Is it about 2,000 plus minus 200 or more 3,000? You see the prediction is the red line, the black line. Red is what actually happened in the end. And what we very quickly found is that while I think this mostly looks reasonable, we always got the right ballpark figures, people would immediately go and say, well, yeah, here your model was wrong. Our estimate was better. And there goes your trust, right? And you would say that, okay, on this day, we expect 2,537 people, but it was actually 2,601. And people say, yeah, but that's wrong. Yeah. No, that was wrong, but it wasn't far off, was it? But you're suggesting something when you present numbers. And people will think, well, that's an AI. That's a smart thing telling me it's going to be 2,537. And they're disappointed if it's not exactly that. That actually happens when you give data back to people. So we engaged with a lot of the key stakeholders. What you see there at the bottom left, this is one of our very first stakeholder engagements, where we ask people, well, would you actually be comfortable if we give you a week ahead or a day ahead prediction and it has this error margin at plus minus 500 people? Would you be comfortable using it if it's just plus minus 200 error margin? And the results of that were actually fairly inconclusive. And it turns out that this is also not really how people think about it, which was part of our learning. But there was a lot of other issues as well. One very important one is the historic bias. Now, this is a term that, excuse me, you might see occasionally in the context of AI ethics when we deal with data from periods where maybe social norms were different than they are today. But it also happens in much more mundane circumstances, such as here, where the models that we thought were actually quite decently working, you can see some of the training results over here. So when there is a certain amount of actual people, we compare this to the predictions. This is never going to be spot on, right? So if you had the Oracle of Delphi perfectly working, that would be a straight line, everything would match exactly. It's never going to be like that. But there is actually a fairly decent match. If you see the curves over time, most of the really intense peaks are actually relatively well captured, right? So that's an okay model. as far as this test case is concerned. Now you take the same model, and instead of this data, you run it on the data just in the month after. And what you're seeing is that the actuals are consistently way higher than what we predicted. So just a month in, the model is just completely off. And we tried really many things, many time periods of it. But the lesson we learned is that, very simply speaking, things change. If you have 20 years of visitor data, there's nothing guaranteeing you that any amount of that is actually indicative of what's happening today. And that was particularly dramatic during COVID, where, of course, people's behavior changed. It was mandated. Right? So there were very big changes, disruptive changes then. But it was not just the pandemic. It is your ticketing models change, right? So someone in marketing has the idea to change the model to annual passes. From one day to the other, everything that used to be an established pattern in how busy you were changes. You run a marketing campaign, how busy you are changes. These patterns break very, very rapidly, actually. And really society as a whole changes. We have, and that is a major challenge today, as well, the cost of living crisis, which just makes it harder for people to spend 30 quid on a ticket. So visitation patterns change, demographics change. And that was a really tough lesson for us to learn, but we had to learn it, and the problems didn't actually go away. Doesn't matter how much historic data you have to assume it's useless. The only thing that's indicative of tomorrow is the last few weeks, months, hopefully, if you're lucky, a few years. The point is, you don't know, you can't assume any of these things. You have to go there and validate that. You have to measure that. And we've always had a really, really close eye on this. And it seems that there has been at least some stabilization approximately as of 2020, end of 2020. So it's for us only been about the last year, really 24, that we were able to use a full year of data and the models still work. Now, early 25, we can use approximately 2 years of data. It's still a bit brittle. You really have to measure that. You have to run that. You have to see how well it works. Is that data still predictive of what is happening today? But you can do it. We have a pretty good routine in that now. And this is what we're doing at the moment, is we're running actually up to 30-day ahead predictions. And they are at this point consistently much better than what humans, managers had budgeted for. You see some of these statistics over here. So this is an error histogram. This shows you that so and so many days the AI model had made this error. And you see it's a relatively tight curve. It's about plus minus 200, 250 visitors off on most days. Whereas in the budget that's shown in red in here, you see much, much larger errors, both positive, you're overestimating, as well as underestimating. There's a particular tail here where there are just some days that are really, really hard to predict for people, in particular long in advance. But if you use data and you use these models, actually you can really reduce the amount of these very big errors. And that's the kind of Chinese New Year level event, right? Where you budgeted for 2,000, you have enough sandwiches and stuff for that, but 4 times that are on site, right? So what this shows is that we can really almost eradicate these kind of really big errors for the management. And that's been a really, really big help. Now, so we do this for 30 days. But of course, we don't just want to tell you we have today, it's the 15th, isn't it? We don't just want to tell you what is going to be the visitor count on February 15th, we want to tell you that and what is the count tomorrow and the day after. We want to do it for all of these 30 days. And that actually is a very interesting challenging of itself, because for some horizons, you have really different kinds of data. Think of the impact of weather, for example. Weather has always been at the forefront of our discussions, and people kept telling us how important it is. And of course, on a sunny day, you would expect more people to show up. Right? Now, the point here is that a day ahead and maybe a week ahead, you have a weather forecast that allows you to do a prediction. A month ahead, you have no such thing. You just know what month it is and what weather typically is in that month in this country. That's all you know. And that means, well, it's a pretty good predictor a day ahead or 2 days ahead. You really need to think differently if you're forecasting a month. Similarly, bookings, pre-bookings are really important. And if we know, well, there's already 2,000 people who've pre-booked a ticket for tomorrow, that's great. That's the cornerstone of a really good prediction. And then we can tune the edges around that a little bit. But a month ahead, most people wouldn't pre-book. In fact, that's a trend in the sector right now. And really in society, it seems that across businesses, people tend to book things much closer to the day. So we know this from airlines as well, who apparently now get most of their bookings a few days before the flight. It's quite incredible. People used to always do these things months, in some cases years in advance. We get a lot more short term. So that means that, applied to Blenheim, a few days before, 2-3 days in advance, the pre-bookings are actually quite good numbers that allow you to make good estimates, because many people have done it already. But a month ahead, no one pre-books that much in advance, actually, or almost no one. Which means if you would ask me what's the best prediction I can make for February 15th, I would look into the database and there's one pre-booking, and that tells me nothing. That's just noise. Right? So again, if you book this much in advance, to predict this much in advance, you have different kinds of information, different features available. So what we're actually doing is, at this time, we're training separate models for these kind of things and weigh features differently. So we can extract this also from data. And we are, and this is to the absolute delight of marketing people now, we are actually able to tell them what part was most important on any given day. So we use techniques here in the area of explainable AI. This example is generated with a library called SHEP that tells you, you made this prediction on this day. How did each of the features have an impact on that prediction value? So what you see here is a 1 day ahead prediction. And what you see is that this year, this is the count of online pre-booked tickets that drove almost all of the prediction. At that point, we had 2,500 approximately pre-bookings, and that accounted for most of what the eventual prediction of 4,500 was. That would look very different if you do this 30 days in ahead, because the pre-book count is useless. You would see other things take place. These are all features here that in different ways encode what kind of day it is. Is it a weekend? What month? Seasonality is it? Those things would gradually take over these predictions. As you see over here, weather is actually very low impact. Now, this is different every day. The way this works is you make this analysis per data point. And on some days, it would be bigger than this. But this has been also an interesting learning for us to see, and for the whole organization to see, is it was a known fact that weather is the driving factor of how many people come to the place. It's not true. On most days, it doesn't matter at all. And there's a number of reasons for that. One reason that we found relatively quickly is that very simply, on most days, the weather is the same. That's the fact of climate in the United Kingdom. On most days, the weather is exactly the same as any other day, for all intents and purposes. For your planning, it's overcast. That's how all days here look like. I'm just reporting the data. right? Um, so yes, there are days, the first hot day in spring, where suddenly a lot of people come. Most days it doesn't matter at all. And actually, that was the second explanation we had. People come on the first hot day in spring. Actually, that wasn't true either, because on the first hot day in spring, people do barbecues and go out with their friends. They come to Blenheim on the second or third warm day. It's difficult, but it's humbling. I tell you, we've learned so much of these weird things where people just knew how it is. And working with data humbles you. It tells you how it really is, challenges your assumption. And this is the learning curve that we're still on. There's lots of other stuff. I'm going to very briefly mention here one important algorithm that we have been developing, which we call the similar day prediction. So this is something that you would recognize from something like Google Maps as well, where you have a predicted business curve, and then you have an actual business curve. So the actual business curve is something that we use based on sensors and filtering. Expected business curves is something that I would suspect, like Google, even though they are not specifically talking about it, we're able to create by looking back and see, well, what day roughly matched the characteristics of this day, and we just pull that item out of the database and say, okay, this is our expectation for today. It's a very nice fallback if you have something that you're interested in and you haven't got the time to create a completely new machine learning model. You can use this to just pull a reference point out of the database. It's really, really useful. There's all kinds of useful things that we can do with this specifically. We can use the comparison between these curves actually to create and send alerts to management staff saying something is happening right now that way exceeds the predicted demand curve in this time period on this day. Right? We can do things like, oh, there's already been 300 people to the loo in the retail store by this point. You better send some member of the cleaning staff over there. That's another very common cause of customer complaints at Blenheim Palace. If you pay £30 for a ticket, you expect the loo to be clean. If it's not, people are unhappy. So this has been one of our most important alerts, to report higher than expected loo usage. I'm going to stop my deep dive here a little bit, and I want to reflect a little bit about this, because what we've been doing here is sort of from a pure research point of view, and I certainly would have considered a large part of my identity as someone who's interested in fundamental research. From that perspective, much of the AI that we're doing here is not that new, maybe. A lot of it is just making it work in a particular context. But that is a challenge. That's a quite spectacular learning trajectory that still keeps giving, and it keeps throwing us curveballs. And I think what is remarkable about this journey, in particular, when you look at the current conversations about AI, is that there's a lot more to AI than large language models. That's what everyone means these days when they talk about AI. But this is not what we're doing. There are reasons for that. Now, I'm going to say right away, actually not, I don't have that on the slides with an example, but we use Gen AI and large language models to do some review analysis, but it's a relatively small proportion of a really big project. Most of what we're doing, and I think this is an important lesson, is really very small data. There's nothing you can do in a problem like that with data-hungry things like deep learning. It just doesn't scale in that way. So these are very, very small data problems. All of these businesses are very limited in size and scope in history. If we assume we can work with 2 years roughly worth of training data, if things work out well, that's just 700 data points. That's nothing. 700. Even the toy examples now we use in machine learning classes have 60,000. That's what a toy example is in machine learning these days. And that has pretty big consequences because the big models don't work. What you actually need is you need very small but very resilient models. And ideally, they are very explainable to create that buy-in and that trust with people. And that's been really interesting for us. And that is basically what we do. We don't try to pull the fanciest thing out of the toolbox. There are plenty of those. We just try to check the simplest thing first. That's been maybe the biggest lesson that we've learned, to scale back our ambitions for fancy models and just see what actually works. And it tends to be the very, very simple stuff, the good old stuff, if you want to say it like that. Right? And there's plenty of challenges in actually making even the simplest models work in a real business context. And I could extend this list quite a bit, but I would say the first two ones to really deal with are actually solving your data integration. Just because you have tons of IT systems and they generate data doesn't mean that they talk well enough to each other to feed this into a live model that feeds into a live dashboard that's capable of creating alerts. You need to invest in that infrastructure, and that's a hard, expensive to solve problem, in fact, surprisingly so. And the second problem I would just raise here is really data quality. Now that goes from someone knocked over the sensor to something covered the ANPR camera with mud and is not counting cars anymore, to someone in the ticketing system supplier company changed the data structure and nothing works anymore. All of these things create data quality problems that break your predictions, your models, they break everything, and often quietly. And that's bad. So one of the biggest, and this is not just technically, but also this is a cultural change and a cultural challenge in the way people deal with data. They care about data, they interrogate it, is to get on top of data quality. And this is not something that you solve, right? It's a change in attitudes and workflows that you have to put in place to constantly look for these things. Are these sensors actually sending? Is the data making sense? Is my historic bias kicking in again and I need to change a different horizon? All of these things you need to be constantly on the watch for. Now, I talked plenty about the predictions and the models. I'm going to spend just a few minutes on how we actually deliver it, which of course is really where the change happens. And there is a lot of different delivery modes that we're using these days. There's different kinds of dashboards for different teams. You see the dashboard over here, which looks really busy. That is just for the operations team. That's the people who manage the tours, the palace hosts, everything that's going on in the palace, people walking you around. And this is a result of years of engagement with them, asking them, what do you need to make better predictions? What are you missing right now? How can we give you that? And what that includes, I'm not going to talk through all of this, it includes all of these busyness curves, live and expected, from the key places like the palace entrance, the different exhibitions, the loo usage, that is very important, right? And don't worry, it is anonymous. To different kind of information of what's open, what kind of sales have been made, and so on and so on. So there's a lot of these different kind of dashboards that are specifically tailored for what different people, different roles in the business need to inform their daily decisions. Daily digests and watch-ups. Now, this is us boasting a little bit. That sometimes is part of playing the game of trust building. At the beginning of the day, we always send off emails to all key staff, managers, supervisors. This is what the day ahead is looking like. This is what we're predicting. This is when it's going to be busy. Expect that. And at the end of the day, we send a wash-up message saying how much better we were than the management budget in terms of our predictions. And most of the days were quite a bit better. It turned out that Well, on this day, we were underestimating the day ahead by 4%, whereas the management budget was off by 30%. That's fairly typical. It turns out one of these weird special cases, you always stumble over these things when you're programming things that we hadn't considered, is that it's actually not that rare that we spot on and we get the number exactly right. And the message kept saying we underestimated by 0%, and that didn't make sense. So now we have a special case written in that says we were bang on. The journey keeps developing. We still have very ambitious goals. This is some of the starting points of the things we're tackling now, where we're now developing purpose-built planning tools for managers to actually feed all of that predictions, not just in an abstract sense back to people, saying, here's a report, but we feed it into the tools that they use for the planning so that they can see, this is the month ahead. This is how close we are to what we have budgeted and what we are currently planning for. This is how many staff hours are currently rostered. You need more on that day. On that day, you need less. Right? So all of this data, HR data now as well, feeds into these kind of things, which if anyone has ever tried to work with an HR system, those are not data integration friendly. That was a long journey, but we got it, right? So for future years, we'll even have data now. This is one of the future benefits of this on historically how many hours were actually staffed. We don't know that historically because that was sitting in some HR system that was only talking to itself. You don't have that record now. For future years, we'll have that. That's a big investment. And with this comes a lot of other tools that go into the rostering domain for different teams. Again, here you see a schematic overview of the site with different routes that different kinds of visitors would take, tick box visitors who want to see everything and so on. And right next to it, you see how many staff hours and how many members of staff are currently rostered. And then we can start to compare this to what is the expected business and hopefully make sure that people get put on slots on the right days where it's going to be busy, and they can be moved out of days where it's not that busy and they are really better rostered somewhere else. Now, this is a very complex planning problem that we're trying to solve in here. There's a lot of contractual, legal, insurance constraints. You can't just let an AI model make free decisions about where to move people. It turns out that's a bad idea for many reasons. But this is something that's in the future now for us, and this is something that we're actively trying to tackle at the moment. So what we're really trying to do here is create a data everywhere culture, business, a data everywhere decision-making. We want to be able to support, blend and work with them, for them to always be able to make the best decisions they can based on the best information we can give them, based on all of this, based on the best predictions and the best AI. People are already exposed to it and use it in their business processes in many ways. One of them that's really hard to ignore is in their staff office, there's a bunch of monitors that just constantly show these dashboards. So we went from, we have data on that, to the head of finance might tap you on the shoulder if you haven't checked that yet. We make it unescapable. And that sounds easy. It's, of course, a dialogue, and it's been a result of years of dialogue. That's led to many formats. We have a bespoke app. We have push notifications. We have alerts, wash-ups, and debriefs, and so on. And it's just not one single kind of problem. Right? It's bringing many different kinds of information predictions into very different kinds of niches within a business, which maybe explains why we are ongoing for 5 years already and keep finding new challenges. It's exciting. So it's been a long road already. Just some of the things to highlight looking forward. We've been starting very actively to engage with the sector. We had some key meetings with really big stakeholders. We had a roadshow that we held last year where people from different visitor attractions combining 29 million annual visitors participated. And we know for a fact that these capabilities are very much desired by other people as well. We're trying to get to a point where we can also practically help other organizations. We're, as a university, of course, but also I think I can say this for Blenheim, we're quite open with these things. Blenheim as an organization is trying to, not maximize profit. They are trying to upkeep a heritage site. So if this works for other heritage sites as well and for society, then all partners of the project are very happy with this. Now, given that this was initially a KTP, we're also contractually bound to commercialize this, but being open and commercialize are not complete contradictions, of course. So we're going into both ways here. We're looking a lot more into smart rostering. I've said this right now, into language processing as well. And hopefully by the end of next year, have a lot more commercial and cultural partners as well to tap into these opportunities. And hopefully this will allow us to also make a difference elsewhere. I think we've made a good difference at Blenheim already, and we're going route to help others to do the same thing. And with that thing, I would very much thank you for coming to this presentation. Thank you for listening, and I'm very happy to take any questions.
Thank you, Matthias. We do have a question on Zoom for you.
Cool.
For the benefit of the recording and our online guests, Lawrence Cox has asked, do viewing figures for related dramas, historical programmes and current news on streaming scheduled services have a bearing on visitor numbers? So that'd be a question around things that would show Blenheim or Blenheim-esque sites.
That is a great question, and I don't have a near conclusive answer to that. We know that marketing campaigns and news coverage have a big impact for very short term. I think a problem there is that it's very difficult to get reliable data on these kind of things. Things like viewerships, we just wouldn't know. It would be very interesting to look into it, actually. I'm not sure we would be able to get that data. It was one of the early ambitions of the project to look into social media, which we haven't been following up on for quite some time because it's a quite noisy channel as well. But this is still something we have on our radar. So I think those are all very good points. And I would imagine that you can learn something from it. How much, I really don't know.
So I'm keeping an eye on Zoom, and please, Zoom guests, do send in your questions. We can see them by the lectern. In the room, are there any questions? Ian?
I was expecting you to be doing something like making the tickets cheaper on a certain day in order to attract visitors. And I didn't see much evidence of that. And then I thought, well, maybe the situation is that you are able to handle no matter how many visitors there are, so long as you know in advance. And therefore my assumption was wrong, but maybe it wasn't.
Dynamic pricing has been a conversation at some point.
Could we summarize that question for the mic?
Yeah.
So the question was whether we looked into dynamic pricing, for example, when there is a less busy day, reduce the ticket prices to drive more people in. So this is something that we have discussed. It's not something that we would immediately consider our competence. Our approach has been very much giving managers the information they need so they make the decisions. And the reason for that is, one, trust is always a big issue. It's already been a very big challenge with something simple as predicting a number. You're much more exposed to trust issues if you're making decisions for people. Because if that goes wrong, your trust is gone in an instant. So we have, I might say, shied back from that a little bit, but I think it is genuinely a much harder problem for which in many cases you won't actually have sufficient data to to really make a grounded decision, because you will not have the data to foresee the consequences of the feedback loop you're starting. So this is something that we discussed and experimented on in quite some depth for the flow management, where one of our lines of thought was, well, if we can predict where people are going, where they know where they're going next, shouldn't we try to steer them in directions actively and make recommendations? And what we found very quickly by even running very simple simulations with that sort of setup is that we don't actually understand the consequences of making that recommendation. And it would mean, of course, that if you tell people the cafe is busy, don't go to the cafe, well, now the cafe will be empty, right? So you're changing the system that you just so painstakingly modeled, and now you don't know what to do. And I mean this very literally. So the problem is you don't have the data to support informed decisions on what is happening then, which is why we focused on making informed predictions about what is happening, how is the future going to be like, on the assumption that the past is indicative of the future. The problem is the moment you make changes, the past isn't indicative of the future anymore because you changed it. And that brings, in machine learning terms, that brings you into the wider problem of reinforcement learning, for which you need gazillions more of data points, which we don't have. So it's a very delicate system that you really need to be careful with, I think. And what you really should avoid, I think this is a big takeaway, is avoid overconfidence in what you can achieve in terms of, I figured this out, I'm going to get this right. Because in most likelihood, you didn't. You get it wrong, and people will turn away.
Gentleman in the corner.
Have you considered having an app, a Blenheim app, to target individual visitors? You five go to the cafe now.
Yeah. Question is, have we considered apps to give individual visitors and maybe give them individual recommendations? So we did, in fact, consider an app, not for the reasons of giving recommendations, but tracking individuals' oversight. So this is one thing that at the moment we don't know, is if one particular person goes through the entrance, where will that person be 2 hours later? We just know, well, there's 2,000 people here and 500 there, but we don't know who's who and where they went through. At least we cannot know exactly. So this is something that was our thinking. An app might solve us, and you wouldn't necessarily have every visitor doing that. But if you have a fraction, you can probably reconstruct quite a bit of the rest. The key reason why we haven't pursued that was the digital divide. And as you might know, most people at Blenheim tend to be a bit on the older end. So there is a lot less affinity to use things like that. So you basically miss most of your key audience and you get a very skewed picture. This was a problem already with the pre-bookings during COVID, where, again, from a data perspective, that was fantastic. Suddenly everyone had to pre-book. The government had, you can't go anywhere unless you pre-book, right? So suddenly we knew everything, all right. But there was a big problem with the audience. And a significant part of the audience didn't know how to use a web page to pre-book things. So it's still something we are considering, I think, but in a different version. There is an ongoing project that I'm not part of, but that Blenheim is doing with some other people at Brookes, that looks into smart audio guides, which will to some extent cover that function. And they will have some individualization about, for example, what has been told a person already, right? So your audio guide is now is intelligent. They won't tell you the same story again. They will start there, connect to it, tell you something else. So that strand of ideas is still developing. It's something that we didn't specifically pick up for this project, though.
Thank you so much. And given the fact that a lot of things you do here is about collecting data, manipulating those data, trying to get some information from those. What are the legal challenges, the legal constraints you have here? Obviously, we know about GDPR, and how much does that impact what you've done?
It's so the challenges. The question is the challenges in legal nature, GDPR, data protection for what we're doing. There is a multitude of answers to that. One of the more critical things that we have been doing recently is actually adopting large language models for language for review analysis. And this is something we have been shying back from for a long time, because as you know, when you use ChatGPT or the respective APIs, that data that was yours now goes away. And that is a challenge for many things. Our approach here has been to use actually a variety of anonymization techniques. These reviews are in most cases not containing any sensitive information anyway. This is stuff that you would mostly find on the web anyway. And in some cases, it was actually Google reviews, so they were out there already. But we have a stack of precautions to prevent leaks there, to prevent anyone from naming people, for example. So this is something that we would filter out for, among other things. Most of the data that we're dealing with, fortunately, from a GDPR point of view, is already anonymized. The people counters are anonymous. They don't know who you are. They carry no sensitive information. This is another reason, actually, why we did not decide for a camera-based solution, because dealing with facial data means you have biometric data, which is very sensitive. And we didn't want to open that door and expose ourselves to those challenges. We did at some point experiment with an integrated camera system that would do everything on the device. So all the image recognition, biometric stuff would happen on the device, and it would never leave it. You only get the aggregated anonymous data. Systems like that are appearing on the market at the moment, but they're quite expensive actually, and they don't deliver much extra value compared to what we're already doing. So we haven't been going down that route, but it's something that you have to constantly think about in a context like this. And we've eventually found that these challenges are very manageable, but you need to be very acutely aware of what the potential issues are, and you need to plan around them accordingly.
So we've got a couple of questions from Zoom. The first from David. Can you use data collected for staff training purposes? E.g., how would you react to the kind of overload situation that happened in the shop on day X?
That's a good question. We are not using it for staff training in that sense at the moment. We are using it for things like daily briefings, stand-ups. So people get looped into these kind of things. Now, I would imagine that these things become part of their supervision and management conversations, but that's not something we are directly a part of. So I wouldn't want to say exactly how it is for them. I think this is a little bit outside of our direct remit. But I think it's a very good point. It's an interesting point. And I'll pick up on that a little bit, I think, later.
And another one we have from Mark. Do the panelists feel that the benefits seen align with the costs of the project? Can they easily justify further investment in developing further / maintaining the systems?
Yeah, that's a great question. And that's the key question we've always been battling with. And of course, the main question that we get when we talk to other visitor attractions, every time we talk to an IT team or a marketing team in another organization, they're always, oh, this is great, I want to have this. But how do I convince my manager? How do we convince finance senior management? And the reality is that we have very limited monetary facts to demonstrate the concrete value at this point. And a big part of the reason for that is actually still COVID, because we have no actually usable baseline, which hasn't made our project easier. It meant that our KTP reviewers from the government were a lot more lenient with us, because it's a challenge that all businesses had. But this, over that time period and extended until 2020, 23, there's very little to actually compare to. Now, I will say that I think the commitment that Blenheim organization has made to this and continues to make, I would value as very concrete evidence of that success, because they keep making that investment. They actually now pay us on a consultancy format and continue to pay our developer, as well as the upkeep of the data hub. So I think after really many years now of work and trust building and confidence building, we're at a point where we have full senior management buy-in and the concrete value becomes very evident. But it is a long journey, and the factual situation is, for me as a scientist, frustratingly difficult, I have to say. It's not easy. But gauging from the buy-in that we get and the interest that we get, I think it must be worth it. That's my assessment from outside of the visitor business, strictly speaking.
And I saw a hand over there. Ryan, please.
Thinking of your remarks about expectations not being satisfied by certain predictions, and then later you mentioned explainable AI. I wonder, over the period of time that you've been working with your collaborators, whether attitudes have changed.
Yeah, I would think so. Attitudes have very much changed, and the trust has been growing. It is something that is very simply a matter of a lot of work and engagement. So very consistently engaging with people, understanding what they need, what information they need, and just continued success in getting these results in has, I think, really now swayed most people. There is, of course, all kinds of pushback that you would always get when you make an organizational change. And some of that is, of course, very legitimate. We're not trying to replace anyone. We're really trying to augment people's capabilities, their insights. But it's something for which I think there are no shortcuts. It needs the building of a partnership and building a system over years that people can engage with, feed into, interrogate, and eventually become convinced that this is actually being useful for them. But it's a challenge.
So we had a question from Ryan.
When you buy a ticket to go to Blenheim Palace, you get an annual pass.
Yep.
But that means that the people that have bought the annual pass, if they're probably mainly local, will just turn up in an ad hoc sort of manner.
Yes.
How does that complicate what you're trying to do?
Yeah,
This
this.
have been called.
Oh, right. So the question is, people get an annual pass when they visit, so people who live locally might just show up immediately without any notice. And that happens. And this is part of our prediction models, actually, to separate these categories, because the visitation patterns are dramatically different. So this is actually one, repeat visitors locally in particular, where weather does usually matter a lot more than for other segments. Because if you have the complete choice when to go and it costs you next to nothing, you'll reserve it for the good days, right? But if you come from the other end of the globe, you just paid £5,000 for a very expensive journey and the bus carries you there, you go into the palace if it rains or not.
Yes.
Right? Yeah. So these are very different curves, actually, and we do, in fact, predict them separately. Yeah.
I think £5,000 is London Marylebone to Oxford Parkway now. I think it's the going rate. We've got one more on Zoom, and then we will see how we're doing for time. So on Zoom, we've got from Will: does Blenheim Palace have its own data science, engineering, or analyst teams, or are the skills and knowledge required provided by Oxford Brookes? And I think by Oxford Brookes, it's implied exclusively by Oxford Brookes. Is what they're asking.
That's a great question. So technically, the data science expertise sits in Brookes, but that is only the case because the associate, the developer that works for us, is technically employed through Brookes, but seconded to Blenheim. And this is the typical model for how KTPs are set up for various reasons. But the point is actually to, through this model, embed the capabilities into the company. And by now we would, I think, for all intents and purposes, count Tahid as much more being part of Blenheim than of Brookes, because that's where he works every day. That's the reality of that job. It's just technically employed through Brookes.
So I think we'll draw the meeting to a close there because we're on 27 past. I'd like to thank Matthias once again for a fantastic talk and answers all those questions.